Hi, this is Maggie from Design Code Debug Repeat. Welcome to the channel. If you're here because you want to learn to program in Java, you're in the right place. This is the 18th video in the Introductory Programming in Java full course and the first video of Lesson 4, Looping Structures in Java. It's important that you've either watched the prior videos and practiced with those concepts, or that you're already familiar with console input and output in Java, and importantly, logical expressions in Java, including the relational and logical operators and Boolean variables, and how they can alter the flow of control when combined with a programming structure such as an if. This will be necessary for understanding loops. Let's get right into it. We gained a lot of power over what code executes in our last lesson with conditional or branching programs. We used logical expressions to test the state of the program, the variables, and if statements, switch statements, and the ternary or conditional operator to direct the flow of control. As an example, here is the switch version of the simple quiz program. This program asks the user a question, gets the user's answer, and then uses a switch statement to determine what feedback to give the user based on their answers. Only one of these feedback statements will execute. Sometimes, though, we want code to repeat, to execute until a certain condition is true. We don't always know exactly how many times it's going to repeat. For example, suppose we want to ask this question, get an answer from the user, and give feedback until they answer correctly. Will they answer correctly the first time? In that case, we show the question only once. Or will it take them several tries, and might they accidentally type a letter other than A, B, C, or D in some of those tries? We have no way of knowing. This is a very common situation in programming, so there is a very common structure to repeat code for us until a condition is met, called a conditional or while loop. It's called a conditional loop because it executes while a condition is true, and we specify that condition with a Boolean expression. Let's change this program so that it executes until the user gets the right answer. So first, what is the code we want to repeat? We want to repeat asking the question, obtaining the answer, and giving the feedback. I'm going to move that line of code that creates the scanner up to the variables area. And then I'm going to put the keyword while just before we pose the question, and then I'll put parentheses where the condition will go, and then an open curly brace. I'll indent all of the code I want to repeat, posing the question, getting the answer, and then giving feedback in the switch statement, and put a curly brace at the end. I'm going to move closing the scanner outside of the conditional code. We don't want to close the scanner until we're done. And, to distinguish those closing curly braces, because there are a lot here now, I'm going to put comments after them, / switch answer for the closing brace to the switch, and / while user hasn't answered correctly for the closing brace to the while, the one we just added. Okay, so then the next question is, when do we want to go into this loop? Just like with an if statement, we'll put that Boolean expression in the parentheses after the keyword, in this case, while. The syntax is very similar to an if statement. The execution, though, is very different. We want to go into this loop when the user hasn't given the correct answer. The answer that the user has given is, or will be, stored in the variable answer. And the correct answer is C. So while, and then in parentheses, answer is not equal to C. Okay, but Java is mad at us. Can you guess why? Think about it for a moment. Maybe pause the video. You should be able to guess that without knowing anything about while loops yet. Have you thought about it? I'm going to mouse over the error. It says the local variable answer may not have been initialized. We've seen an error like this before. So the problem is, we need to go into this loop until the user answers C, and in order to do that, we need to test answer. But the user hasn't answered yet. We haven't posed the question yet. There's no value in the variable answer. Let's talk about how this will execute, and then we'll fix that error so it will work. First, let's talk about how the while statement works. We reach the top of the while loop, line 12, sequentially after creating the scanner. And Java will execute the test, answer not equal to C. If that test evaluates to true, if answer is anything other than C, then we will go in and execute the conditional code, the code in the curly braces. Just like an if statement, if the condition is true, we execute the conditional code. All of the code will execute. The question will be posed, the answer will be obtained, and feedback will be given. Now here's the big difference between a while loop and an if statement. Once the loop body, the code within the curly braces, has finished executing, execution always returns to that first line of the loop, line 12, the line with the keyword while. The test is executed again. If it's true, we go into the loop again. That happens over and over and over until the test is false. Okay, so that's how a while loop functions. It's pretty straightforward. But how do you build a correct loop? A correct while loop executes exactly as many times as you want, or exactly when you want it to. And it does exactly what you want. It doesn't, for example, pose the question to the user again after they already got it right. So our loop should pose the question and get the user's answer at least once, and then if the user gets the correct answer, it should stop. But if they don't, it should do that all over again and again until they get it right. So to build a correct loop, you will need to properly maintain any variables that are used in the test. In our case, that is one variable called answer. The variable needs to have a value before the test. That's the error that's in our program currently. It doesn't. And then it's tested. And then somewhere in the loop, it needs to get a new value so that at some point when we come up to the test again, it's going to be false and we get out of the loop. A loop that never ends is called an infinite loop, and that's a bad thing. I call the variable that is controlling the loop, the variable in the test, the loop control variable. The code before the loop that gives it an initial value is called the initializer. Then we have the test, and then somewhere in the loop there needs to be an updater, a line of code that gives the variable a new value. In our loop, answer is the loop control variable. We need to add an initializer. The test is answer not equal to C, and the updater is line 20, the line on which we obtain an answer from the user. Hopefully, they eventually give us the answer C, and the loop ends. So let's get rid of that error by giving answer an initial value. I can do that when I declare it. Now there are basically two things we can do here. We can give answer a dummy value, like X, that will get us into the loop. I'm going to do that, but I don't love that solution. The other thing we can do is get an answer from the user before the loop, and then loop as long as the answer is wrong. I prefer that, but I don't like copying and pasting this code because we could make an error and it will basically double the size of our program. With what we've learned so far, I think giving the variable a dummy value that will get us into the loop the first time is the best answer. In another video, once we've talked about loops a little more, I'll show you another solution that's better, but that isn't available in all programming languages. So let's run the program, and then let's run it in the debugger so you can watch the flow of control. I'll give a few wrong answers. I'll start with A, and notice I get the feedback, and then I'm prompted for another answer. It could probably be neater, maybe with a blank line, but notice I didn't have to run the program again, it just asked me for another answer. I'll enter B, and then D, and then E, and I get the I'm sorry, that wasn't an option feedback, and now I'll answer C. And the program has ended because C ended the loop. Let's put a breakpoint at the top of the while. I'll right-click in the margin next to line 12 and choose Toggle Breakpoint. And then I'll click the bug to run the program. And I'll click Switch. And the program has stopped on line 12. And I can see answer has our dummy value of X. So the first line of our while loop is reached sequentially. The test will always execute at least once. If it's false, we never enter the loop. Just skip to the first line of code following the loop's closing curly brace. If it's true, we go in. Because answer is X, the test answer not equal to C is true, and we go into the loop, meaning we execute the code that's in curly braces. I'll step over. And it's printing out the question. I'll keep stepping. Now it wants an answer. I'll type A at the prompt and press enter. And Eclipse highlights for us in the variables section that answer has changed. We can see it's A now, and we're at the switch. I'll step over. We go into the A case, and if I step over, it prints the feedback for A, and then we're on the break. So I'll step over, and notice now we're back at line 12. The switch statement was the last statement inside the loop body, inside the curly braces, and now we're back to the top of the loop. And answer does have a new value, but it still isn't C, so the test answer not equal to C is true, and we'll go into the loop body. Now this will repeat. Java printing the question and accepting an answer, the switch statement providing feedback, and going back to the top of the loop for every non-C answer given. I'll give one more bad answer. I'll answer E. And notice after the loop body, we're back at line 12. Now I'll do it again, but this time I'll answer C, and pay attention to what happens. Notice we're back at line 12. Control always returns to the top after executing the body of the loop. We know this test is going to be false now, but Java doesn't know that. It always goes back up and executes the test. Now I'll step over, and now the test is false, so control flows to the first line of code after the loop. Now, what do we know is true once we've made it past the closing curly brace of the loop? We know that the loop entry condition, answer not equal to C, is false. So we can put an assert at the end of the loop, assert answer equals C. I'll stop the execution, switch to Java mode, and I'm going to go to Run Configurations in the Run menu, x equals arguments, and type -EA for enable assertions in the VM arguments. And if I run the program and type C, Java doesn't throw an assertion error exception, so my assertion is correct. And importantly, it might be easier for you to think about certain loops by thinking about what you want the state of the program to be when the loop is done executing. In this case, we want the loop to be done executing when the user gives the correct answer, or when answer equals C. Sometimes it's easier to write this logical condition than the loop entry condition, which is the opposite or complement. You can review the video on complementing Boolean expressions in Lesson 3 if you need a refresher on that, because it can be helpful when writing loops, especially if you find it easier to write the condition when the loop is done executing than the loop entry condition. Okay, so that's an introduction to loops, but there's much more to cover, so I'll be back with more content in this lesson in the coming weeks. As usual, I have included an auto-graded exercise in the description of this video so you can practice with the code. When you're feeling confident with the concepts in this video, you're ready to move on. As always, have fun and keep coding.